Mr. Claxon's Algebra 2 class, or maybe my algebra class, depending on at what point we're at in the year. Just wanted to show you the goals that we did discuss, or that I wanted to get through today. Ended up, we got through all of them, although we kind of had to condense everything there at the last minute. The goal is to classify that exponential function. Okay. In this example right here, and this is in your notes, I wanted to make it apparent to you that f of x equals x squared is not an exponential function, right? That is a quadratic. You should know that as a quadratic. It's not exponential. So I didn't have you write that in your notes, but definitely need to recognize that it's not exponential. The blue function, however, is 2 raised to the x power. Is an exponential function. I can identify that as exponential because I have a base and a variable in the exponent. And as you can see, it starts off growing very, 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 very slowly. This actually isn't touching the x-axis. It starts growing at a greater and greater rate, and it will definitely eclipse the red function there. As you can see over here in the table to the right, it definitely eclipses that red function, even well, after x is 4. We can't see that, but to the right of x is 4, and so 5, 6, 7, 8, 9, 10, so on and so forth, it is going to grow at a greater rate. So I know it doesn't look like it right then, but it will definitely when x is greater than 4. Looking down here, just when given an exponential function, when the base is greater than 1, the function will grow. That's what's happening up here. It's growing exponentially. When the base is less than 1, it will decrease exponentially. And just to give you an idea for what exponential decay is, I'll show you a quick graph. You know, maybe you've forgotten how to graph. This would be a good review of how to graph. And I'm just going to throw in there 0.92. So 92 hundredths raised to the x power. And what does that graph look like? And you can see how that decreases exponentially. And I could adjust my window here so you can see more of the graph, or zoom out. You can see it's not going to touch the x-axis. I'll go ahead and zoom out. So zoom 3. So you can see that just what the exponential decay looks like, that exponential decay. Now, in addition to learning about exponential functions, we did discuss some common misconceptions. We also discussed the compound interest formula. They have it written in function form, right? Function form. A of time, or A with respect to time, the amount with respect to time, is equal to the principal multiplied by the quantity of 1 plus the rate divided by the number of times it's compounded per year, raised to the number of times it's compounded per year, multiplied by the number of years. Now, all those variables are explained down here. This by adding 1 to it, it does represent growth. Now, I wrote it and conveyed it to you like this. We do need to give props to the function notation. Function notation, right? That is in true function form. We need to start looking at formulas in terms of that function notation. When using that formula, there are several mistakes that can be made on the calculator, and I don't want you to miss these just because you didn't get the opportunity to learn in class. So common mistakes that I want to show you. Number 1 is not using parentheses. If you use the TI 84 Plus Color Silver Edition, you must have parentheses. I took a screenshot of it there. This does not have parentheses, and it does not give me the right answer. This is number 30, by the way. Number 30. Number 30, the correct answer is $3,262.04, the correct rounded answer. It does not have parentheses. Because it does not have parentheses, it gives me the wrong answer. If you're using the TI-83 Plus, you want to make sure, in addition to using parentheses, you can see the parentheses right there, in addition to using parentheses, you want to make sure that your exponent is either just a number, a regular number. In this case, it would be 2 times 20, which is 40. Or you must put that exponent, those numbers being multiplied, in the exponent. You must put those in parentheses as well. I made the recommendation to everyone in class today just to go ahead and do the work. Just go ahead and do the work. What would be work for this one up here? It would be writing it, A with respect to 20 years, set equal to 1,000. I would like you to use commas. It helps to clearly communicate numbers if you use commas. And then, let's just use a little mental math. 0.06 divided by 2 is 0.03. 0.03 added to 1 is 1.03. So 1.03 raised to the 40th power. That is work for this. So, if you're taking a quiz or a test and you want to pick up some of those, at least half credit for showing work, that is how you can show work for it. And if you do show that work, you're guaranteed at least half credit, even if you make a mistake on the calculator. But notice, which part is wrong down here, which form is wrong, and which form is correct. So please review these common mistakes so that you don't make the same mistake, right? I also discussed with students how to use a basic function calculator. How are we going to use a basic function calculator to calculate compound interest? So in the next slide, I do have the written directions here, so I know that you can read. Feel free to pause and read this. I'm just going to go ahead and show you how I would do one like 34, right? So 34, we're given a principal of $1,800 with a 5.65%. And again, that's 5.65%. And that's compounded daily. 5.65% was what was given in the problem. Compounded daily, that's 365 days, right? So the first thing that I really want to do, if I have a basic function calculator, is I want to multiply that 365 times 6, if I can't do that in my head. So 365 times 6, okay, I'll write that down off to the side, 2,190. Okay, from here, I want to clear my calculator out. I have to follow the order of operations in order to get this correct. So I have to pay attention to the parentheses, right? Inside the parentheses, I have division. So PEMDAS, parentheses, exponents, multiply or divide in order from left to right, means I need to divide 0.0565, which is just a decimal version of rate. Need to divide that by 365. Now when you divide that by 365, you're going to get this very, very, very small number, right? That's 1.5479452, so on and so forth, times 10 to the negative 4th. I'm going to add 1 to that. So add 1 to that number, and you can actually see 1.00015479445. I don't, in order to be more precise, I want to keep that number on my calculator, and I'm just going to take that number and raise it to the 2,190th power. So the exponent button on many of the scientific calculators, if you turn your iPhone sideways, right, you should see a little button right here. You want to raise that to the 2,960th. Oh, I messed up. All right. 190th power, right? That's going to give you still a decimal in between 1 and 2. You want to multiply that decimal in between 1 and 2 by your principal. So now multiply that by 1,800. And now, now that you know how to do this by using a basic function calculator, you can do it whenever you want to. Instead of getting on, Facebook, MySpace, Snapchat, Twitter, you can calculate some compound interest here to see how much money you're going to make off your investments. Considering you have investments to make. So I hope that that you were able to, if you were absent from class, you were able at least to watch this 10-minute video to get caught up on what you need to do.